I'm currently off Mars for an internship back at Earth. However, I can still tell you what our robot is doing in this project, why our robot's doing it, and how exactly our robot will do it. So what is our robot doing in this project? Our robots, the single sensor line follower and the double sensor line follower, are performing a series of basic movement patterns to build coordination and precision among these robots. The reason why our robot is doing this is to calibrate and test our robots to ensure that they can move accurately and also work together. Before we can do anything like construct buildings and also just keep maintenance, our robots must be capable of coordinating together and moving along with each other. We'll get this done by writing Python code to be able to control their forward, backward movements, and rotating movements, and adjusting their speed and angles and also sensor responses until both robots are able to move precisely and accurately to each other. This ensures that our robots are fully calibrated and ready to go on Mars.
So guys, how are we actually gonna program a robot so it actually functions in the field? What's your ideas, Cam?
I was thinking that we should use ChatGPT. I mean, it's quick, it's efficient, it doesn't take much time to get a good result, you know?
Okay, I agree. It gets the job done a lot more quicker, and you don't really need human input, especially if it gets done with 99% accuracy.
We shouldn't use ChatGPT because the code should require some human input. ChatGPT can be unreliable sometimes.
Yeah, but with its 99% accuracy, I feel like that it would be reliable in most case scenario without human input.
Exactly, and I agree. And I was like, my boy, it doesn't take much to get a good result, you know?
Okay. So,
I guess we can try that.
let's try ChatGPT.
So here's the ChatGPT code.
Okay.
It's pretty tough. Let's run it.
Wait, why isn't it working? Why is this thing on?
Guys, I told you we should use ChatGPT.
Yeah, but ChatGPT is good.
Yeah, it's a great idea.
It is a great idea.
Me personally, I thought it was the best idea.
The Lappy Toppy must be, bro.
Yeah, it's gotta be a laptop. Laptop.
The only other option is to use human input. We should do it ourselves and see if that works.
Okay, fine. Let's use our actual brains this time.
Yes.
Okay, fine. This stanza of code is going to provide real-time related functions like mathematical functions, control our large motors, and set up our sensors so they actually work in real time. This stanza of code is going to assign our large motors to different output ports, port A and B, and this is going to align the motors just for convenience, just so it could basically just run easily. And our motors have sort of a tank drive steering system. So basically, each motor will move independently, and the steering style will be combined, driving and steering, as a tank would normally operate. This standard code will create sound and speaker operation and create a button object to detect EV3 button presses and virtual communication, because in the end of the day, we also have to communicate with our robots to make sure we get the job done.
Alright, this next section detects the colors and light intensity, as well as measuring the distance to nearby objects, and then it proceeds to detect rotational angle and rate, and it also has a virtual GPS sensor and a virtual drawing pen that are both simulations. Additional motor attachments is a magnet motor that controls pickups. It uses magnets to do that, and that's it.
3, 2, 1. Yeah. One by drift. Other move too fast. Had to test that twice. Now they gonna be last. Yeah, code in my head. Don't need no pack. Fix 1 line. Now the shit come back. Yeah. Way too rough. How to balance that pain. Math and loop. Now they moving the same. No talk. Just flash. Both boss. Insane. Work all night. We don't chase no fame. Yeah. 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 Yeah, that was a really good beat. I think that was a good
I made the
attempt.
I didn't feel like
Oh, yeah.
So our first difficulty was matching up the speeds of the robots because they're different weights and stuff. So it's one that's a big body one, then a regular one, you know.
We resolved these issues by testing different speeds together, so to see how big of a difference they were at sync, so then we could initially solve our issue.
Back on Earth, I'm here to tell you what we learned in this project. From our past difficulties, we learned the ratios for the different robots to move accordingly. In the future, we'll use the ratios to be able to set the speed for the different robots and ensure they move cooperatively.